Thank you. So for those of you who don't know me, I'm Razvan, and I'm a pull request and issue manager for the D-Language Foundation. So before we get into this, I just want to share with you so what's the purpose of this talk? When I started contributing back in 2016, DMD as a library was one of the first projects that I contributed to. And what struck me is that I was kind of the only one doing work on this front. And that was a bit odd because it seemed that this was a very important project for the development of the ecosystem, right? So I did work for a bit. I even have a talk on this. But progress has been slow, and that was mainly due because although most people consider this to be an important project, the expectations and which direction we should go don't actually match up, right? So it was kind of hard at times to make progress because there were some people that were having some sort of, well, they didn't approve the additions and so on and so forth. So since as of this year, this has also become one of the D-Language Foundation's priority, I figured that I would just bring together like all of the past decisions and what has been done up so far, mostly to kind of create a sort of database for people that want to contribute on this front, but also to kind of spark up discussions on how to move forward. So what I'm going to touch in this talk is we're going to talk a bit about how compilers are organized and see exactly how DMD basically is organized. And then we'll see what are the goals of the compiler library, what has been done so far, the limitations, future work, and conclusions. Okay, so basically, I guess most people in this room are familiar with the compilation phases, but for those who are not very well versed in compilers, you basically have the source code, which is a text file, and then you have lexing. You transform basically the source code into a stream of tokens. Tokens can be identifiers, delimiters, keywords, and so on. And then in the next phase, which is the parsing phase, you use those tokens, you consume them, and you create an abstract syntax tree, which is basically a representation of your program. Then during semantic analysis, you traverse this tree, and you enrich this tree with type information. After you've done that, you do code optimization. So basically, you try to get a minimal version of this tree, right? So that when you generate code, you generate the least possible code. Now, this is like a general organization. You may also have like some sort of intermediate code generation after you've done the optimization pass, right? And then do another optimization pass on the intermediate code, and then finally do code generation. Actually, DMD does have some intermediate code, but that's not very relevant here because when we're talking about DMD as a library, we're mostly referring to the front end. So it's basically the first, let's say, 4 stages: lexing, parsing, semantic analysis, and code optimization. Now, let's see how DMD implements all of these phases. So basically, lexing and parsing is done in the same phase. So initially, if you had like a separation between lexing and parsing, you would first go through the file, through the text file, and create a stream of tokens, and then you would have to like get every token in sequence, right? Well, DMD does this at once, so you have like a lexer class, which gives you the next token, or you can allocate a token, or peek past a parentheses, and so on and so forth. And then you have the parser class, which can parse a module, an expression, a declaration, and so on. And basically, the parser methods called the lexer methods, and they create an AST. Now, the AST is formed of some classes, and these classes also are put up in hierarchy chains. So for example, for expression nodes, you have the root node, which is an expression, and then you have binary expressions, call expressions, unary expressions, and so on and so forth. And there is an inheritance chain there. That's similar for declarations, for symbols, for statements. Now, what's interesting here is that the AST nodes contain all of the information that you need for a specific node, right? So for a compiler developer, so this is when I started working on. So currently, there has been some progress on this. So the organization that I'm presenting now was back in 2017. Now it's a bit different, but we will get to that, okay? So what was interesting is that semantic analysis and the optimization pass were all methods in the AST nodes. And after the AST is created after the parsing phase, you would just traverse this AST by calling, for example, semantic on the function declaration node. And then that particular method would recursively call semantic on the children nodes, right? So in this example, where you have the function, which has a type, a void type, it has a parameter declaration. Here you would also have the string as a type node, but for brevity, I didn't include that. And then you have the body of a function, which contains an array of statements. One is an import declaration, the other one is a call expression. So when you called semantic on function, you would then call semantic on the body. And there are multiple semantic phases, but that's not very relevant for this talk, right? So in short, this is how DMD is organized. So you have lexing and parsing, and then you have AST nodes, and that's all to it. Now that we are accustomed with how DMD organizes its code, let's see what are the goals and how we should transform the code so that we offer it as a library. Well, these goals we didn't extract them from a specific use case that we had. We kind of looked at what LLVM was doing with its compiler libraries, and we tried to do the same in our case. So we wanted to have a separation between compilation phases. As you've seen, that wasn't, I mean, the phases were separated, but if you wanted to just build a parser library for some reason, that wasn't possible, because you needed the AST nodes, right? And the AST nodes contain semantic information. So if you wanted to create a parser library, you would still end up to package the entire compiler code base over there. We wanted to have the ability to modify AST nodes. Again, that's not possible. I mean, you can subclass those classes, but you can't actually modify them. You want to have the ability to modify the compilation phases, right? So if you want to do semantic analysis differently for a specific node, you want, for example, if you have A plus B, and for some other reason you want to do subtraction for them, you should be able to do that. And that also wasn't possible. Also, you want to have the ability to ask the compiler for any kind of information. Any kind of information that the compiler has, you should be able to query it, and that also isn't possible because as the compiler developers know, semantic analysis creates and destroys some information, or can create or can delete AST nodes, and so on and so forth. So after you've done semantic, the tree doesn't really resemble its former representation. We also want to have the ability to use multiple instances of the compiler in the same program, right? So imagine that you're implementing a language server protocol and you want to compile things in parallel, right? So currently the compiler does share some global state, and it's impossible for you to do multiple things in parallel. So for example, if you have some code and you want to compile it with DIP1000 enabled, and also you want to compile it with DIP1000 disabled, you cannot do that in parallel, because you basically have a global variable which says if DIP1000 is enabled or not. And also we wanted the library compiler and the release compiler to share the same code base, right? We don't want to have different code bases for this. And we don't want our changes that we make to create an API for the compiler library to incur a performance penalty for the release compiler. What we weren't concerned of was incremental compilation. So at the point where I started, incremental compilation seemed like such a far distant goal, and even as of today, I can't really envision the changes that are necessary to get DMD to do incremental compilation. Maybe it's possible, but I think the code base, or maybe it would just be simpler to implement it from scratch than use the existing code base. And also, we don't really care that much about compiler library performance. At first, we just want to have a decent interface so that people can start using it, and then we can see if we can optimize it. But the compiler is already pretty fast, so if you're reusing that code, then you should be fine in most cases. Another thing that we're not worried about is the potential compilation slowdown when compiling the compiler, right? So the compiler code base was initially written in C++, and it didn't use any templates or operations that require compilation time. So if we are going to use more modern features of D, which basically come with the compilation slowdown, then we don't care that much. Now, let's see with these goals in mind what has been done. So we templated I'm just going to list what has been done, and then I'm going to go in more detail about each of those. We templated the parser with an AST family in order to break the dependency between parsing and semantic. We also extracted some semantic analysis from AST nodes so that we have it in a form which is easy to be modified then by users. And then we tried to use the library for the existing projects. And a simpler thing that I just listed here, but I'm going to go in depth, is to customize error handling. So before DMD, I mean, it still has an archaic error handling system, but now you can customize it, right? So if before it would just, output to standard output or standard error, you can now pass in some files where you can redirect the output for errors. So now let's see what templating the parser with an AST family did. So this is a simplification of how the compiler code, how the parser used to look like. So as you can see, you need to import the lexer because you're going to subclass it, but then you end up importing all of the AST nodes in the compiler. And since the AST nodes also contain semantic information in them, you end up indirectly importing other files that you might not care about. And then what you do is you implement the parsing methods and you create AST nodes to create the AST. What we did was basically to template the parser with an AST family. So the user of the library is going to provide the AST family that the user wants to use, and then we're basically going to create the tree using those nodes. How does an AST family look like? Well, for example, for the release compiler use case, you're just going to import the existing AST nodes, right? And basically, you obtain the same behavior. But if you want to modify the behavior, or you want to instantiate the parser, and then maybe just do a pass with the AST that it does, but not to do semantic analysis, then you can use AST base, which contains all of the nodes that the parser requires, but these nodes in AST base are stripped of the semantic information. So they don't have fields or functions that are required for semantic analysis. Now, this kind of breaks the dependency between parsing and semantic, but it also came with a big cost. Like AST base is a bunch of duplicated code, and there were some people that weren't satisfied with this solution. So how do we fix this? Well, one way is to extract all of the methods and fields that rely on semantic information so that you end up having AST base be the same as AST codegen, right? So this is kind of the principled approach. You extract all of those functions, you put them in a file, and then AST base and AST codegen are going to be basically the same structures. But there is another approach which I tried, and that is to extract all of the functions and fields that are common for both AST codegen and AST base and put them in a mixin template, right? And then you just mix in this code in both the AST nodes in AST codegen and in the AST base nodes. Of course, you're still going to have to duplicate the declaration of the AST nodes, but that's just going to be class something, blah, blah. Okay, well, this pull request actually has been turned down because it uglifies the code, but still, I mean, and I agree, it does uglify the code, but mixin template is like a valid feature of D, right? So if we're not using it internally because it uglifies the code, I don't see why we are expecting that other people are going to use it, right? But anyway, I kind of continued on the line of the first approach, which was to extract all of the semantic analysis routines from there and created some visitors. So to have a better grasp on what this meant, this is how the AST nodes look like. So you have a binary expression which inherits an expression, and you have a function which basically does the semantic, and then you can have an assigned expression which inherits from a binary expression and also overrides the semantic method. So what we did was basically pull out these expressions, so you can see in the after code that you don't have any semantic over there, but you use a visitor class, which contains all of this information in a different file, right? So right now, basically these AST nodes just contain some fields now and some methods that are being used. And after I did this, I kind of moved on to other projects in the D-related area, but I had a student, because this was kind of a simple project, right? You just pulled out some code, you put it in a visitor, or put it in a different file. It could be done easily by a bachelor's student. And she worked on this for a while before people started wondering why are we moving all of this code from one place to another? It's really not that obvious what this gives us, right? I mean, we're acting on principle, but we don't really have a use case. So with what we have right now, why not just try to get a use case, either by, I don't know, using a tool, getting a tool in the ecosystem and trying to use the MD as a library over there and see like, how does the interface look like? Do we really need this? Maybe we are fine as we are. So we started doing that, and the first project that we did was DCD, and then DScanner. Now, what is DCD? It's a decompletion daemon, so basically it just gives you when you're writing decode, it gives you some suggestions on what symbols to use. It uses libdparse, which is a third-party library that does parsing, and it uses dsymbol, which is also a third-party that kind of creates symbol tables by using libdparse, right? So it doesn't really do any semantic analysis. It just has a tree, it goes through that tree, and if it finds a symbol, it just puts it to the table there. Now, when we tried to use DMD as a library here, because we figured like we have semantic analysis in DMD as a library, right? So we're going to have like much better results than DCD does. But it turned out that it was much more complicated than that, because what that initial image with the abstract syntax didn't contain is the scoping information. So when you're doing symbol resolution, basically you need some scoping information to make sure that you have access to a symbol, right? So how does that work? Well, the function declaration, assuming it's at module scope or at SUMEVER scope, it's in S1. But then the parameter, it's not on the same scope level as the function, right? So how this is stored, you have the second scope of the parameter, which has a reference to the first parameter. It makes sense to do it like this, because, for example, when you're calling writeLine and you're in the third scope, to resolve writeLine, you need to go up the scopes or in imports, right? So it makes sense that you have a pointer to the upper scopes. You don't need pointers to the scopes that are going down, because like you're not doing symbol resolution that way. And this is great, this all works for the release compiler, but sucks if you want to expose the scopes, right? Because these scopes are created during semantic analysis. After you've done semantic analysis, you don't have these scopes stored anywhere, right? And even if you did, let's say you would have like S4 and S5, all of the leaf nodes, that doesn't help you, right? Because for symbol resolution, basically you have one line in the source file and you need to get all the available scopes at that line. And at that point, we kind of got stuck. Like the student which was working on this implemented a sort of a hack, which was fine for his bachelor thesis, but we didn't really have a solution for this back then. But I mean, we could do it, right? We could just save the scopes somewhere in the library version. Yeah, so the lesson that we learned here is we need to publicize scopes. Without those scopes, we can't do anything like maybe even implementing unused import tool or unused variables or so on and so forth. Now, the second project with DScanner, we had a lot more success. So basically, is anyone here who doesn't know about DScanner? Okay, so basically DScanner is this tool that is used to kind of implement style on code, right? So it also uses libdparse. So we wanted to replace libdparse with DMD as a library, and we've had much more success on this. Actually, there was a talk at DConf last year by the student who worked on this. And we had to do some Lexer modifications, like we added a range interface. We had to lex white spaces in new lines, because again, lexing in DMD is very fast, so you don't care about white spaces in this. But if you're doing like a tool where you want to make sure that, I don't know, you have 2 or 3 white spaces between your identifier and the parentheses, then you need this information. And while we were changing the Lexer, again, there were some discussions on the pull request, like, why are you doing this? This is going to come with like a performance penalty, or even if you put it in the version, DMD-lib version, people were like, you're uglifying the code. Why not just use like, why not just inherit from the Lexer and then use your own Lexer? But that wasn't possible because if you remember the code, the Lexer was just defined, yeah, so the Lexer looks like this, right? Class Lexer inherits Lexer, so I cannot customize it. But you could potentially do it, and it's actually cool that this works. Like you get a second template parameter, which is the Lexer, right? Which by default points to the Lexer that exists in DMD, and you just inherit it, right? So this also works. And we also noticed that not all AST nodes have location information, or in some cases the location was wrong. So we fixed that. And this project is, I would say, 70% done, but the student now was hired at Microsoft, so he's not working anymore on this, but I'm in discussions with another student to pick up the work, and hopefully by next DConf, we're going to have DScanner use DMD as a library. Now, what are the current limitations? Well, the biggest limitation is that we still cannot currently insert AST nodes with the AST family. And I have here an example. Like, let's say you want to, I don't know, log all of the binary expressions in your AST, right, in your code. For you to do that, maybe you just want to add an extra field to the binary expression nodes. How you would do that? You would basically inherit the existing bin expression and add your field here and then just import all of the existing AST nodes, right? Because you want to reuse everything. And then you just say the new binary expression is my binary expression. But this has an obvious flaw. Can anyone think of it? And basically these 2 lines of code are a hint on why this doesn't work. Yes?
So children need to inherit from my bin expression, but they inherit from the old bin expression.
Exactly, right? So here, assign expression inherits from bin expression. I have successfully replaced with my AST family, so the parser is going to create my bin expressions, but assign expression is still going to inherit from the old bin expression, not from my bin expression. So we need some sort of mechanism to also express the relationship between the AST node inheritance chain. And I am currently exploring a way in which maybe these AST nodes could be templated with a parameter which basically represents the AST nodes that you are inheriting. Hopefully at the hackathon maybe I can implement this. Other limitations, like you still cannot obtain the scope information, but if we are able to insert AST nodes in the AST family or in the AST inheritance chain, then you could potentially solve that by just adding a scope field, or maybe existing, because there are some AST nodes that do save some scope information, and just save that scope, right? And at the end, when you are traversing the tree, you can just use the scope for each AST node. Also, information still gets lost during semantic passes. Like the most popular example is aliases, right? So if you have an alias and then you're using that alias in your code, the compiler is just going to replace it, and you have no idea if the new symbol was an alias or if it was just a normal symbol. This sort of information is important when you are developing tools. Most classes and methods are extra in C++. So initially, the compiler frontend was developed so that GDC and LDC can hook into it and then use their code generators. And this is kind of annoying, because, like, for example, if I want to subclass an AST node, I have to also make it extra in C++. Otherwise, I cannot override its methods. And this has some sort of limitations because extra C++ functions cannot use some of the functionality that normal D functions use. Of course, you can just mark what you can mark them as extern deep, and that's going to work. So it's not a very big limitation, but still can be annoying in some situations. And also, one thing, if you're going to use the compiler library, be careful because DMD uses null terminated strings. So one bug that we've had is that what we typically do when we use the compiler library, you just read the file, you have the text, and then you hand it over to the parser, right? The parser receives a string, but then when it passes it to the lexer, it actually passes the pointer. So your string is not null terminated because it has a size. But then when the lexer starts lexing, you end up like reading garbage. So if you have some time and you want to contribute, there are some things that you can do to advance the state of the art for the compiler library. And actually, I have in mind some projects that I'm trying to advance. And one is to finish the dscanner integration of DMD as a library. I'm currently discussing, as I've said, with the student to pick up this work. And also, there is a person that applied that symmetry atom of code to integrate DMD as a library in D format. I'm currently trying to implement an unused import tool also to see what's necessary for the interface. And I also need scoping information there, so we need to find a way to implement that. And also, I think it's desirable to extract more semantic information from AST nodes, because right now we have AST base, which is a pile of duplicated code that keeps accumulating and keeps being out of sync with what we have in AST CodeGen. And ideally, I would like to get to a point where you can basically specify all of the compilation phases and the AST nodes when you create your compiler, right? So you just say new compiler, here is my parser, here's the AST family that I want to use, here is the lexer that I want to use, and here is the semantic analysis that I want you to do. And ideally, you can reuse as much of the existing code in the compiler code base to do that. So for conclusions, we started with an initial set of goals, and here let's see if we manage to reach them or not. So to have a separation between compilation phases, right now we kind of have that. So you can do lexing, you can do parsing, and you can without doing semantic analysis. The only thing that's kind of a bit problematic is that the optimization pass is still tightly coupled with semantic analysis, right? So ideally, you would do you would have the ability to do semantic analysis without doing optimizations, and then just invoke the optimizer if you want to. But right now, that's not possible. To have the ability to modify AST nodes, I think that we are almost there. So that's why it's with yellow. It's almost green. We almost have it. I'm hoping that by the end of this week, I'll have a pull request that advances this. And also have the ability to modify the compilation phases. We can do that. So right now, all of the semantic routines are actually in the form of visitors. So you can just inherit the existing visitor and overwrite whatever semantic method you want. You would still have to probably now it depends, like semantic routines, some of the functions have even hundreds of lines of code. So if you just want to modify a particular action, you would probably need to copy paste the entire code and just modify that one little thing. Unfortunately, I don't know how else you could do that apart from maybe, I don't know, just getting small chunks of code and refactoring them out into functions, but I don't think that that's a working solution. Now, have the ability to ask the compiler for any kind of information. That's kind of complicated right now, but I would argue that if we have the ability to modify AST nodes, then you could just create your own AST nodes that kind of store the information that you need, and then you do a pass and you obtain it from there. So I think that if I manage to finish the second bullet point, then this fourth one, I have 30 seconds. Yeah. Yeah, we still have global state, so we cannot use multiple instances, and yeah, the library and the release compiler do share the code base, but what I want to stress out is that it's necessary that we have extra code that only the library uses. And I know that most of the compiler developers are reluctant to do this. The solution up until now is to just version it out with version DMD as a library. but that makes the code more ugly. But on the other hand, like you cannot have a compiler library and just not modify the code base at all, right? So you need to kind of stuff some sort of code that's going to create a better interface in there. And up until now, yeah, so there's no performance penalty for the release compiler because we didn't actually, we didn't add code for the release path. All the code that we've added was under version DMD as a library. Yeah, I've put some useful links here if you're interested and if you have any questions.
So I have actually two questions. One is about your unused imports tool. And I've seen there's some false positives on the unused import tool because it's a complex way to get unused symbols from that because we have public imports. And when we import a module, we can't really know if the symbol is from that module or from a public import. So we need to traverse the imports recursively. Is this an issue that you are aware of and you are going to fix it?
So right now what I've did, so the import tool, it's still in a basic phase. So it just imports global imports that are not being used because I don't have scoping information, right? So it doesn't do like function level imports. So yeah, I imagine that once you have all of this scoping information, you will be able to do more complicated stuff. But yeah, you also have imports in templates, right? So if you just have like a file where you have a template declaration and you have an import there and you have only that file, you have no instantiation, you're not going to be able to tell if the import is used or not.
Yeah, yeah.
And also with the aliases, right? So if you have an import of an alias, there is, like, if that alias is substituted in the file that was imported, there is no way to know if the alias was used or not.
Yeah, I did some changes on the compiler regarding to that, but I think we need some more work to get some compiler information from that.
Yes.
And another question is about the modification of AST nodes. Is that extending AST nodes, or is a feature that we can actually mutate the AST? So with your changes, will we be able to mutate the AST or just extend it?
So if I get the question right, if you want to define your own AST family.
Mm-hmm. Yeah, not define my own AST family, but actually the same AST but modifying, like transform it.
Yes, you can. If you specify, so the AST is modified by the existing semantic routines. Now, if you are using the existing semantic routines, the AST is going to be modified in your code. If you provide your own AST routines, yeah, you can do whatever you want over there.
Because modifying AST has a problem where if we modify a type, for example, we need to ensure that is conforming with the semantics. So we need to run the semantic analysis again.
Yes.
Okay.
Yes. Yeah. So, yeah, it's going to be a bit more complicated. Like, for example, yeah.
I just want a note of appreciation of what you're trying to accomplish, Razvan. Those who don't know the internals of the compiler, what he's doing is like trying to convert an internal combustion engine car to an electric car and having each intermediate stage be a fully functioning car. So I admire and appreciate your efforts in this, and you know he's really taken on a tough task to get this done.
Thanks.
Hello. If I can make a brief note, more than the question, but a lot of the kind of things that are being discussed here is not so, like you mentioned, scoping information. The kind of the general issue is that we don't have a dependency graph in the compiler. So if you imagine, you know, we have a
Sorry, I can't hear you.
we need a dependency graph.
Okay.
in the compiler. So you wouldn't you can effectively just write a semantic garbage collector. So if you have a import statement or even just any AST node with no edges leaving it to anything else, then you can look for it and try and cull it. Whereas if you try and kind of specifically start with importing things and then work backwards to what you need, basically just going to get stuck in. It's partly DMD hell, but also just compiler hell, because it's not a sort of traditional thing you can do with an AST. There isn't really a question there, I'm afraid.
Yes.
All right, we can squeeze in one more question if you've got it. Going once, going twice, nothing. All right, that's it. Thank you, Razvan.